Alright, so let's take a look at this example here, okay? So whenever you're dealing with these quadratic area word problems, the first thing you want to do is you want to make sure you read the question carefully and make sure you understand all the information and what's going on, okay? So we have a rectangular playground, right? So I've drawn this rectangle here, and it says the measurements of the playground, all right, is 13, right, meters by 7 meters, okay? Now, basically what's happening is this: if you increase the length and the width by the same amount, so we're going to make the length and the width, we're going to increase it by the same amount. So we're going to make the sides longer by some amount, right? It's going to be the same amount. So basically what's going to happen is the rectangle will get bigger then, right? Now, we don't know what this amount is, so we'll call this amount here x. So it's the same for both sides, x, right? So what that means is the new measurement for this side here, right? So this was 13 before, and then now we've added x. So this side here is now going to be x plus 13, right? The length of this side. And this side over here, right? So before it was 7, and then we added the x. So this side over here now is going to be x plus 7. Okay? So now this is really important information right here. It says you will increase the area of the playground by 261 square meters. Okay? So that means that the area of the playground will go up by 261, right? It doesn't mean the new playground will be 261 square meters. So you have to make sure you understand that, okay? So now we know the area of a rectangle is the length times the width, right? So the area of the rectangle, so before we increased the sides, the area here was 7 times 13, which is 91. So the area before was 91. And the question says it's going to increase by 261. So we need to add 261, right? And that'll give us this gives us the area of the new bigger rectangle. And then our two sides, we have x plus 7 and then x plus 13, right? So what you want to do next is just kind of multiply on the right side here. Let's multiply that out. We'll get x squared plus 13x plus 7x, so that'll give us 20x. 7 times 13 is 91. And on the left side here, if we add those together, we get 352. Now, since we have a quadratic, we want to make it equal to 0 so we can solve it. So we make it equal to 0, so we end up with x squared plus 20x, and then minus 261. All right, if you can use a calculator to do this problem, right? Let me show you how to do it on the TI Inspire. So on the TI Inspire, we want to go to Menu, Algebra, Polynomial Tools, find roots of polynomial. If it's a quadratic, the degree will be 2, so just click OK. Right, and then once you have this quadratic in standard form equal to 0, all right, just type in the a, the b, and the c values. So a is 1, b is 20, c is negative 261. So a is 1, b is 20, and c is negative 261. All right, and you can just click OK, click Enter, and then we get our solutions. So using the GDC polynomial tools, we find out that x is equal to negative 29, and x is equal to 9. Now you need to think, do your answers make sense, right? So this side right here, right, that we increased by x, so remember x represents this length amount right here. So this length amount here cannot be negative 29, right? Like a length cannot be negative. So this doesn't make sense, so we reject this answer. So you need to make sure you say that you reject this. So you know that x should equal 9, okay? Now let's make sure we answer the question. So go back and make sure that you answer the question, right? Because sometimes it's not asking for x, it's asking for something else. So it says find the amount that you should increase both sides by. Okay, so we found that that's 9, right? And what are the new dimensions of the playground? Okay, so basically x is equal to 9 meters, right? That's what we should increase both sides by, right? And then the new dimensions, so if you plug 9 for x, so 9 plus 7, that'll give us 16 meters by, and then 9 plus 13, that'll give us 22 meters. So this would be the dimensions of the new bigger rectangle. Okay? Okay, let's take a look at this next example here. Okay? So this says a square field had 5 meters added to its length and 2 meters added to its width. Okay? So let's draw a picture of what's going on here. So first of all, let's sketch a square. So we've got a square. So here's a square. And this says 5 meters was added to the length. So one side here, so the length here, let's say 5 meters was added, right? So this is 5. And then the other side, 2 meters was added to the width. So 2 meters was added to the width. So this is 2. So then after we've increased it to 2 sides, so we have this rectangle now. It says the field then had an area of 130 square meters. Find the length of the side of the original field, right? So this is the square here. This is the side of the original field. So we'll call this x. Here we go. Now, this whole side here is going to be x plus 5. This whole side here is going to be x plus 2, right? Now, it says once the sides were increased, the field then had an area of 130. So the area of this whole big field now is 130. Okay, so you need to read the question carefully and think, is it saying the area of this whole thing now is 130, or did it just increase by 130? Okay, so be careful about that with these questions. So we know the area, right, of a rectangle is the length times the width. They're saying the area of the new bigger, right, shape is 130. The length, so the two sides, we have x plus 5 times x plus 2. So you want to multiply this out, we'll get x squared plus 7x plus 10 is equal to 130. So we've got a quadratic, so we make it equal 0. Right, so we want to make it equal to 0. Right, plus 7x minus 120. Once this quadratic is in standard form and it equals 0, right, we can just use the calculator, right, like we did with the last example, right? And then remember, go to menu, algebra, polynomial tools, find roots of polynomial, and then the degree will be 2, so that's okay. And then just put in the a, the b, and the c. So a is 1, b is 7, and the c is negative 120. And that'll solve the quadratic for you. Click OK, click enter, and then we know x is negative 15 and 8. So we use the GDC, we're using polynomial tools, right? So we got x is equal to negative 15, x is equal to 8. Now you want to make sure if your answers make sense. So remember, x represents the side of this original field. So we know that this negative answer doesn't make sense. So we reject this answer. So you want to make sure you reject this. So we know the original field is 8 meters, right? Find the length of the original side of the field. So that's going to be 8 meters. This is our answer right here. Okay? Okay, let's take a look at this next example here. So this says a rectangular lawn measuring 8 meters by 4 meters is surrounded by a flower bed of uniform width. Okay, so first of all, we know this rectangle inside here. The measurements are 8 by 4. Okay, and what's happening is when you see this word uniform width, that means that it's the same width going all the way around the shape. Okay, so basically this is the flower bed right here, and it's the same width going all the way around the shape. So they're saying that this width right here, whatever it is, it's the same going all the way around this rectangle, right? So whatever this is, it's the same. The combined area, so this is important, the combined area of the lawn and flower bed is 165, okay? It says, what is the width of the flower bed? So the width of the flower bed is this right here. So we're going to call this our unknown. So this is x. So this value here, x, right? That's our unknown. Now let's set everything up. So we know that this whole side here, right? So this length here was 8 before. And then what did we just do? We added x and we added x. So this side now is going to be 2x plus 8, right? Same thing over here. The other side, right? So before it was just 4, and then we added x, and then we added x. So this side over here now, right, is going to be 2x plus 4. Okay, so now let's set everything up. We know that the area is equal to the length times the width. So the area says the combined area, right? So the lawn and the flower bed is 165. So we know the area is 165. Is equal to, so we take the two sides, we multiply them with each other. 2x plus 4, 2x plus 8. So we work this out, we get 165 is equal to 4x squared, right? Plus, that'll give us right there 16 plus 8, that'll be 24x plus 32. Okay, it's a quadratic. Let's make it equal 0. So we get 4x squared plus 24x minus 133. Okay, and just like the previous examples, once you have the quadratic, right, in standard form set equal to 0, right, if you're allowed to use a calculator for the problem, right, you don't have to worry about trying to factor this. You can just use the calculator to figure this out. Okay, so we're going to use the GDC. Remember, we're using polynomial tools, right? So I like to write this just to tell the person grading, like, how do I get my answer, right? So I use the calculator, right? So 4, 24, and negative 133. Those are our values. So go to algebra, polynomial tools, find roots. So my A was 4, B was 24, and C was negative 133. Just click OK, click enter, and then you'll get your values. So negative 19 over 2 and 7 over 2. So we know x is equal to negative 19 over 2, x is equal to 7 over 2. Okay? Now remember, our x represents the width of this flower bed. So we know this negative answer doesn't make sense, right? So we reject this answer. So no, the correct answer is 7 over 2. So 7 over 2 is the same thing as 3.5, right? So x is equal to 7 over 2, or you could say it's 3.5 meters, right? That's the width right here of this flower bed. Okay? So it says Ms. Lin's rectangular flower garden measures 20 meters by 30 meters in size. She plans on doubling the flower garden's area by adding a strip of uniform width, right? So whenever you see these uniform width questions, make sure you're aware of them. Determine the width of the strip around the flower garden, okay? So the first thing we always want to do is we want to draw a picture and make sense of the information, okay? So first we have a rectangular flower garden, right? So here's our rectangular flower garden. So it measures 30 by 20. So this is 30 by 20 meters right now. And basically what's happening is she's going to increase the size of this, right, by putting a uniform width border around it. So whenever you're dealing with a uniform width question, so basically you should be thinking, well, there's going to be like some sort of border around this, right? There's going to be like a border put around this. And this border is going to be the same width going all the way around. So whatever this width is, right here, whatever this width is, it's going to be the same going all the way around, right? So we'll just call it x for now. So we're trying to determine the width of the strip right? The uniform width right here, right? So let's set everything up. So we know this side right here, this was 30 before, and then we added x and x, right? So then that's this side here now is going to be 2x plus the 30. This side over here, so before it was just 20, and then we added x right here, and then x amount, right? So this is going to be 2x plus 20, right? And then it says that she plans on doubling the flower garden's area. So whatever the area was before, she's going to double it. So the area before, right, was, so before she made it bigger, it's 20 times 30, which is going to give us 600. So this was the area before she makes it bigger. So let's set everything up. So we have the area is equal to the length times the width. So the area of the new bigger rectangle, so it's going to double. So that means the area will be 2 times 600, which is 1,200, is equal to the length times the width. So our two sides are 2x plus 20, and the other side is 2x plus 30. And then let's multiply on the right side here. So we've got 1,200 is equal to 4x squared plus 100x, and then plus 600. And then since we have a quadratic, we're going to set it equal to 0. So we get 4x squared plus 100x minus 600, right? And once again, if you're allowed to use a calculator, I would just solve it using the calculator. It's much easier. That way we don't have to try and factor this thing, right? So we're going to use the GDC polynomial tools. So once again, so our A, B, and C, so 4, 100, and negative 600, right? So using the Inspire, go to Menu, Algebra, Polynomial Tools, Polynomial Roots, right? So the degree is 2, click OK, and then just put in the ABC. So 4, 100, and negative 600. Click OK, click Enter, and then we've got our answers. So negative 30 and 5. So x is equal to negative 30, x is equal to 5. So once again, our answer, right, we have to see if they make sense. So if x is negative 30, so x represents this, all right, length here, right? So we know that cannot be negative. So we're going to reject, all right, this answer here because it doesn't make sense, okay? And then over here, well, we know that the correct answer is going to be 5, right? So to make sure we answer the question, determine the width of the strip around the flower garden, okay? So we know that it's going to be 5 meters, right? So this is going to be the measurement of the width of the strip, the uniform width, right, going around the flower garden.